Hello everyone, welcome back to another video on the tutorial series where we take a look at the OpenCV library together with Deep Learning for Java library, in which we are trying to solve a Sudoku puzzle. In this video, we are going to be taking a look at how we can train our network to actually recognize the digits and try to print out the value that it recognized. What we have here is a so-called classifier. So basically what we are doing here is we have a set of images and we want to classify them. If you take a look at our training set, we have different folders going from 0 to 9, and inside of them we have images. And our network, what we want to do is take a look at this image and say, yeah, this is a 3, I classify it as a 3. Or I take a look at this one, this is a 4, I classify it as a 4. The labels here are important, so they must be labeled from 0 to 9, so that it knows which values they belong to. And we also have a testing set, which is exactly the same, so it just has the same values. We just use it for testing to see if our network is actually any good. So let's see what we do here. We have a few things here. We have resource folder path, so it's just a path to the folder where we have all of these things. So this is exactly what I just showed you here. So testing, training with the digits. And then we have a height of the image and width of the image, and we have number of samples for training and for testing. I have 204. You can have as many as you want, the more the better. And we have number of outcomes. We can have 10 outcomes because 0 to 9. And then we move on to the main method. In the main method, we just configure our we use the basic configurator to configure all of the necessary things for the deep learning for Java. And the important part for us is the dataset iterator. So we want to be able to iterate through our dataset. We gave the path to our training folder and the number of samples that we have there. And in this method, what we want to do is we want to get the folder and we want to list all of the files. We want to list these digit folders. And with that, we also have the image loader and pre-processing scaler. And with that, we are taking also a look at our input and output arrays. We want to create two arrays. The input one is, again, number of samples and height by width. So that's one array, and the other one is number of samples and outcomes. And then with that, we are just iterating through our data set. Not sure, yeah. So we have iterating through our data sets. We have our digit folders, so folders named from 0 to 9. And with that, we are trying to get the label. So we get the name of the folder, which is the label of the digit. And then we list the files inside the folder, which are the image files. And with the image files, we turn them into a row vector. So this int array. And we use the scalar to transform it, and we put it into the input array. And we put it on a certain row, so we have this index here, then we can put it on a certain row, and we also put the label on the same row. And with that being done, so we will iterate through all of the folders, through all of the images, and we will have our input and our output. The next thing is we create a data set, and then this data set as a list, we just shuffle it and we return this list data set iterator with the shuffled list data set, and we have the batch of 10. All of these classes are coming from the Deep Learning for Java library, so you can take a look at them there on their implementation and see what they do. So let's take a look at what we do next. The next is the build model method. So we have the dataset iterator, and in the build model, we build our configuration. So we build our network. We are using the multi-layer configuration. You can play with the values and see if they work for you, if they work better. I just copy pasted this ones from the Deep Learning for Java webpage. You have a bunch of examples there. They have like a big project on GitHub. You can just take a look at that and copy all of the values if you want to, or you can take a look at which ones does what. I will not be going into details, but you can take a look at different loss functions, different activations and stuff like that, whatever this does. If you're interested in it, just give it a look there, and they have a really nice documentation and everything is nicely explained. But with our configuration, we build our model, so our network. We initialize it, we set some listeners. So basically this will just print every 500 iterations, it will print a score and tell you how good your network is. And then we train it. So the fit method is training it, and to train we use the dataset iterator, so we can iterate through the dataset. And here we are doing the same. We're building again the dataset iterator, but now on the testing. And with the testing, we are running the evaluation, and we're printing out some stats, and we are writing the model to this archive. So we can actually run this. So it will be retraining the network again, and we can see the results, and we can see what it actually does. So you can see that it started here. Score at iteration 0 was 2.5. Blah blah. You can see that accuracy is 1, which is super nice. Again, this is because we have a really small data set, and yeah, here you can see the stats printed out. It's quite simple, quite easy, and it's really fast because we are not using many data, so it's actually quite nice for us. The next thing we promised to take a look is, if we go to our Sudoku solver, is how we actually solve our matrix. So if we go to Sudoku matrix and then we go here, how we estimate the value. We use this eval util and we evaluate the image. So we have the cell, which we saw in the previous tutorial. So it's the cut out cell. If we go back to resources, digits, it's one of these. So for example, let's say we took this one, and that's the cell that we're passing in, and we have our train network. Okay, we have to explain how we got the train network. The train network is coming from the load model. We are just using this model serializer to restore the multi-layer network, and we give it a path to the one where we saved previously, and we load it in. With the loaded network, we are just passing it here. So our trained network is going here. We are trying to evaluate the image. So we have the image that we want to evaluate. We have our model. We create the input array and the image array. So we are using the image loader here, same as we did before, and transform our image into the raw vector. And after it has been transformed, we use the scaler to transform it again. We put it in a row of the input. It's at the position 0 because we just have one image here. Then we have the data set created of a number of outcomes. Again, it can be 10 outcomes. And then the model output is the predicted array. So the model output gives you a predicted array using the features from the data set that we created here. All of these things are copy pasted from the deep learning for Java page, which I'll be linking in the description, so you can take a look at there and see how they do it and why they do it like that. But with that, we are just trying to get the predicted value, which is we are using the Boolean indexing. So we take the first index from the predicted. So it will just take the index of the value which has the max number. So they have like you have different values, like for example 0.5, 0.6, 0.99, and it will take the index of the one that has the max number. In our case, that would be 0.99. And with the predicted value, we just throw it to string and parse it as an integer and return it once it's evaluated. So this is something that we put in our matrix, and voila, it's printed in this one. If I run it again, so we're now using our newly trained network. Hopefully that works again. And yeah, it does. So here you can see that 4, 6, 8, 9, 1, 2, those are all of the solved values coming from the method that we saw. Let me just see if I missed something here. No, it's quite simple actually. We can get rid of some stuff. Yeah, so this would be everything for this video. I think maybe in some of the next ones we could actually take a look at how we can what we could do. Maybe take a camera and try to take the input from the camera directly instead of passing the image. Do write me in the comments if you would like to see that. If not, yeah, then we have this, and I will not be creating any further videos. This was just a simple project where I would explain you all of the things that you can do. Of course, I'm not an expert here. I'm just trying to figure out how it works also for myself. But yeah, hopefully this helps you in your projects and you understand a bit better how OpenCV works and how deep learning for Java works. If you like this video, please do like it and subscribe to my channel, and I will see you in one of the next ones.